This video is sponsored by BetterHelp. Declassified files have revealed that in 2014, nearly 3 years before Oumuamua made headlines, an unusual object struck our planet on January 8th. It penetrated Earth's atmosphere, leaving fiery trails across the skies of Papua New Guinea, and ultimately crashed into the coast of Manus Island in a dramatic explosion. Although data recorded by the sensors of certain spy satellites suggested that the object likely originated from interstellar sources, this information remained classified, shrouding the meteor's origin in mystery for years. However, recent ongoing research has finally confirmed that the mysterious meteor did indeed originate from another star system. This object has been named Interstellar Meteor 1, or IM-1. Chronologically speaking, this discovery establishes IM-1 as the first known interstellar visitor, preceding 2 subsequent objects. But how did scientists confirm that IM-1 originated outside of our solar system? Moreover, why did it take almost a decade to confirm the origins of this celestial object? To answer these questions, let us journey back to 2014. When IM-1 impacted Earth on January 8th that year, it was documented as C-NEOS 2014-0108 in NASA's Center for Near-Earth Object Studies, or C-NEOS data collection. As the meteor traversed Earth's atmosphere, the sensors aboard secret spy satellites operated by the U.S. Department of Defense detected an exceptionally high registered speed for the object, indicating that it could not have originated from within our solar system. 5 years after the incident, in 2019, Harvard scientists Avi Loeb and Amir Siraj classified this object as a potential interstellar meteor. However, the data source for their classification was exclusively spy satellites. Furthermore, in compliance with defense protocols, the U.S. government did not disclose the exact precision of the measurements. Due to these constraints, the 2 researchers could not publish their findings, leaving the question of whether IM-1 was genuinely interstellar or merely a chance occurrence unresolved. However, in 2022, the U.S. government conducted a more thorough examination and finally confirmed the accuracy of the data. U.S. officials released a document validating the work of Avi Loeb and Amir Siraj, conclusively declaring IM-1 to have an interstellar origin with a confidence level of 99.999%. But how did Harvard scientists initially confirm the interstellar nature of IM-1? The answer to this question lies in the object's speed and trajectory. Based on data collected by spy satellites, the meteor was found to be traveling at a velocity of 45 kilometers per second, or 28 miles per second, when it entered Earth's atmosphere. This speed accounted for both the object's motion relative to Earth and Earth's motion around the Sun. However, when other contributing factors were subtracted and the velocity was compared to the mean motion of celestial bodies within the solar system, it became evident that the object exhibited a significant deviation of 58 kilometers per second from the mean velocity. This deviation in speed is characteristic often associated with objects originating from stellar systems in the thick disk of the Milky Way. Moreover, the data of the detected meteor showed that it originated from an unbound hyperbolic orbit, indicating that it had escaped from its system and traveled away from its primary body. All these unique features strongly suggested the possibility that the meteor was indeed an interstellar visitor, with a confidence level of 99.999%. Once the interstellar origin of the meteor was conclusively established, the next challenge was to decode its chemical composition. This required the retrieval of meteorite samples from the impact site. But there was one problem. IM-1 had exploded near Manus Island, scattering its fragments over the Pacific Ocean near the coast of Papua New Guinea. Consequently, the team faced a challenge of collecting interstellar samples from the depths of the 2,000-meter deep seabed. Nonetheless, a dedicated team was assembled to recover material from the deep seabed. Over 2 weeks, they meticulously covered approximately 64 acres of seabed around the impact site. This effort enabled researchers to compare the normal seabed material from the unaffected area and the material from the impact zone. Here's where the story takes an intriguing turn. Examination of the minute fragments retrieved during this process yielded remarkable results. The fragments were found to be rich in 3 elements: beryllium, lanthanum, and uranium. Notably, the abundance of lanthanum and uranium exceeded terrestrial rock levels by 500-fold, while the beryllium content surpassed Earth's levels by 100 times. This discovery was particularly significant because the presence of beryllium is indicative of exposure to high-energy cosmic rays, providing further confirmation of interstellar travel. Furthermore, the isotope ratios of iron within the sample defied our understanding of the solar system. All these findings further established its interstellar nature to a greater extent than before. Based on the chemical composition, it was found that the meteor might have been a component of a larger parent body, such as a giant asteroid or even a planet. However, scientists also raised the possibility that it could have been technological debris from extraterrestrial civilizations. Furthermore, another possible interstellar candidate, IM-2, crashed offshore in Portugal in 2017. According to the calculations, it appears that interstellar objects of this kind might be more abundant within Earth's orbit than previously believed. With all these findings backing up the interstellar nature of IM-1, it becomes clear that it is the first known interstellar visitor, predating the famous cigar-shaped interstellar object discovered in 2017 and another rogue comet named Borisov, discovered in 2019. Before ending this video, I want to take a moment to thank today's sponsor, BetterHelp. I know starting therapy can be challenging. Maybe the right therapist for you isn't nearby, or perhaps, like many, you find face-to-face interaction a bit daunting. That's where BetterHelp comes in. BetterHelp is revolutionizing the way we approach therapy. It connects you with a licensed therapist who's not just trained to listen, but to provide helpful, unbiased advice tailored to your needs. You can have your sessions over a phone call, video chat, or even messaging. Whatever makes you feel most comfortable. Plus, scheduling is flexible. You can arrange therapy sessions at times that fit your life, not the other way around. And if you feel your first match isn't quite right, which is pretty normal in therapy, BetterHelp lets you switch therapists easily and at no extra cost. No stress about insurance or network constraints. So if you're considering therapy, click the link in the description or visit betterhelp.com/secrets of the universe. This not only supports this channel, but also gets you 10% off your first month of BetterHelp.